Hello everybody. So in this video I'm going to discuss a new chapter, that is chapter 4, and the name of the chapter is Motion in a Plane. Okay, so in this chapter we're going to discuss about the scalars and vectors. Okay, and I'm sure that you are familiar with this term. These terms are not new to you. All right, so let us see one by one what are these scalars and vectors. So first of all, a scalar quantity, or simply scalars, they are physical quantities that has magnitude only and no direction. Okay, they have only magnitude and no direction. What is the meaning of that? Magnitude only, that means the amount, the size. All right, but it has no direction. For example, work. Okay, time. Okay, when somebody asks you the time, you just say the time. Maybe it's 5 o'clock or 6 p.m. or maybe 7 a.m. but you don't say it's 5 p.m. south or 6 a.m. towards the right side. No, you don't say like that, right? Because time has no direction. So similarly, the speed has no direction. Okay, it's just the magnitude, distance. When we say the distance of 2 points. Okay, so let's say a body is going from point A, it is traveling like this, and it is going to point B. All right, so the distance is the length of this path traveled by the body as it goes from point A to point B. So it is the same as the length going from point B to point A. All right, so the direction here is not important. Only the length, the magnitude is important. So that is why distance here is a scalar quantity. Any number, 1, 2, 3, 4, any number, okay, any integer, those are scalar quantities. They don't have direction. When you write a number 4, you don't say that 4 is towards the right side or towards the left side or anything like that. It's just the magnitude out here. Energy also has got only magnitude and even density. So all these quantities, they are called scalar quantities, or simply scalars. On the other hand, vectors, they are physical quantities that has both magnitude and direction. For example, force. Okay, so force here, when you apply force to a body, all right, so let's say you have a body, here. Now if you apply force, let's say this body is on the floor. If you apply force to the body in that direction, then this body will move in the direction of the applied force. Yes or no? If you apply force to this body, let's say this body, if you apply force in that direction, now this body will be moving in that direction. All right, so whenever you apply force to a body, the body goes in the direction of the force. So that means, and how big, how much force you are applying. Maybe you're applying just a small force, so this body will go slowly. If you apply a larger force, then this body will go faster. So force here has got both magnitude and direction. So for that reason, it is called a vector quantity. Velocity as well has a direction. Okay, acceleration, momentum, pressure, displacement. All right, so displacement, when a body is going from, let's say it is starting from point A and it is going to point B. What is the displacement of the body? The displacement of the body is simply the line joining the initial position to the final position, and the direction is always from the initial position to the final position. Okay, because it is starting from point A and going to point B. Got it? So here the displacement is the length of this line AB, and what is the direction? From point A to point B. And similarly, torque has a direction as well as magnitude. So all these quantities are vector quantities. Okay. All right, so let us discuss more about the vectors. Okay, so first of all, the representation of a vector. That means how is a vector represented? A vector is represented with a straight line having an arrowhead. Okay, the length of the line represents the magnitude of the vector. Magnitude means how big the vector is, right? While the arrowhead represents the direction. Okay, so for example, you have a line like this, a straight line, and this arrowhead is going from A to B. Okay, so therefore we write the vector as AB with a bar sign. Okay, with an arrow bar sign. Got it? Now it is starting from point A and going to point B. So B here is the tip of the vector and A is the tail of the vector. Or you can have a vector going from B to A. So in that case you write BA. Okay, is AB and BA the same? No. They might look the same. They might look the same. You might say that they may have the same length, but they are not having the same direction. So this is a vector AB bar. This is a vector BA bar. Why? Because it is starting from point B and is going to point A. So here B is the tail and A is the tip of the vector. Got it? So that means all these quantities like force, velocity, acceleration, is it here? Yes, all these quantities, force, velocity, acceleration, momentum, pressure, etc., all these, they can be pictorially represented by a straight line having an arrowhead. Vector notation. Now how do we write a vector? Any vector is denoted by A with a bar sign, or R with a bar sign, or capital A with a bar sign, or capital P with a bar sign. So basically it is any letter. You can denote a vector with any letter, but there should be a bar sign on top. Okay, so some books, they write simply, let's say a vector R, they write simply like this. All right, so this also can be represented, can represent a vector. But then more strictly speaking, this is the average. All right, so it's better for us to write the arrowhead as well. Understand? So it is written as A bar is equal to A bar modulus. This sign, the two vertical lines out here, these are called the modulus sign. All right, A bar modulus, and modulus represents what? The magnitude. Okay, you don't take the sign of this. This is the magnitude with a cap. Can you see this small arrow mark out here? Now this and this is not the same. All right, so this is nothing but a unit vector, or we can simply write A bar is equal to A into a cap. Okay, where A modulus, A bar modulus, or simply A is the magnitude of the vector A bar. Understand? So whenever you write a vector with the modulus sign, what does that represent? It represents this part. It represents the magnitude. The magnitude of the vector. Let me rub off this small r out here. Okay, and this and what? And a cap out here is the unit vector, and the unit vector here, it represents the direction. Okay. So whenever you write a vector, so this vector has got both magnitude and direction. The magnitude is represented by the modulus of that vector, and the direction is represented by the unit vector. All right. Sometimes we write the model instead of writing the modulus, because sometimes you can just write like this, A without a bar sign. Okay. All right. Now, what is a unit vector? A unit vector is written as A with an arrow mark on top. This is read as A hat or A cap, because this looks like a cap, because like a cap that he's wearing on top of his head. Yes or no? So this is like A hat or A cap. This is not a hat, not a cap. Sometimes we can denote the unit vector by R or by any letter. How do you read this? This is R hat or R cap. It has a magnitude 1 or unity. All right, so magnitude 1, so that means this vector, it is a vector. Okay, it is a vector, but then its magnitude is 1, maybe 1 centimeter, 1 Newton, or maybe 1 millimeter, so on and so forth. So whenever the magnitude is 1, we say unity. So we can also say that it has a magnitude of unity, and it represents the direction of a vector. So what is the role of the unit vector? The unit vector, it represents the direction of a given vector. All right. So a unit vector A hat is equal to a vector divided by its magnitude or by its modulus. Okay. Let us look at some properties of vectors. So number one, equality of vectors. Now when are two vectors said to be equal? Two vectors are said to be equal if they have the same length and point in the same direction. You remember or not, the length here, it represents what? It represents the magnitude, right? The length is representing the magnitude. Okay, the magnitude of the vector. That means how big the vector is, how small the vector is. All right, so if you have a vector, let's say force, which is 10 Newton and 20 Newton, right? So 20 Newton has larger magnitude. Okay, 100 Newton has even larger magnitude. Velocity, 2 meter per second and 15 meter per second. Which one has more magnitude? 15 meter per second has more magnitude, is it not? So here, when we say that two vectors are said to be equal if they have the same length or if they have the same magnitude and point in the same direction. Okay, so here I've drawn two vectors, two lines out here also. Okay, you can see that this blue line and this purple line out here, right? They are both pointing towards the right side. Okay, so this is a vector A bar and this line is a vector B bar. So I can write it doesn't matter whether they are anywhere. Okay, this vector, it can be here also. It can be here also. Let me use that same color. It can be here also, this vector B bar. Understand? But always the length should be equal and the direction must be the same. Understand? So then only we write A bar is equal to B bar. Okay, so when can two vectors be equal? If they are having the same magnitude, that means same length, and pointing in the same direction. Okay, so both the magnitude and the direction has to be satisfied. Negative vector. A vector is said to be negative to a given vector if it has the same length, that means magnitude, but opposite in direction. Can you see this vector A bar? It is, look at the arrow mark out here. A bar is pointing towards the right side, but this vector B bar is pointing towards the left side. But then if you look at the length, they are equal in length, is it not? So how do we write this? Mathematically, we write A bar is equal to minus of B bar. Okay, so this is a very important concept out here. When you will come across this many times. All right, A bar is equal to minus of B bar. Whenever you see this, it means that the two vectors are equal in magnitude. Okay, because if we take the modulus sign, if we take A bar modulus, this will be equal to B bar modulus. Modulus, we are neglecting the minus sign, yes or no? So here, once we take the modulus, then we can see that they are having the same magnitude. Again, what does modulus of a vector represent? It represents the magnitude. So they are having the same magnitude. But then this negative sign, what does it represent? It represents the oppositeness in direction, which means that these two vectors are opposite in direction. Okay, so we will come across this, for example, in gravitation chapter. In gravitation chapter, you have F12 bar is equal to minus of F21 bar. Okay, now what does this equation mean? It means that the two forces are equal. All right, the force of, let's say I have a body here, this is a body M1, and I have another body here, this is a body M2. So there is a force that this body is acting on that. So in that direction, no, not in that direction, it is attracting. So M1 will be attracting M2 with the force F12, right? And M2 will be attracting M1 with the force in that direction with the force F21 bar. Okay, and from the vector form of the universal law of gravitation, we get this equation. All right, so F12 is equal to minus of F21 bar, which means that the two forces are equal in magnitude. The force with which this body is attracting this is equal to the force with which this body is attracting that. But the two forces are opposite in direction. How do we know that they are opposite in direction? Because of the minus sign. Is it clear? So I told you that this is going to be a very important concept. Okay, just remember that if you have any vectors like this, they are equal in magnitude, opposite in direction. Okay, right. The third property here, multiplying a vector by a scalar. When a vector r bar is multiplied by a scalar s, it changes to s r bar. You don't write the bar sign on top of s because s is a scalar. Okay, you write only on top of r, which is a vector. The magnitude increases s times, but the direction is not affected. Can you see? Suppose you have a vector here, a vector r bar. Now when you multiply it with s, then the length it increases depending on the value of this. If this is less than 1, then in that case the length of this will decrease. Okay, it may be, let's say, it may be only till that much. Got it? Depending on the value of s. All right, but the direction, both the directions are the same. The direction is not affected. Understand? And what about if we multiply a vector by a real number? When a vector a bar is multiplied by a real number n, it becomes n a bar, just like multiplying with a scalar, because number here is a scalar. The magnitude increases n times while the direction remains unchanged. It can increase or decrease. It can increase or decreases n times depending on the value of n. If n is larger than 1, then it will increase. If n is smaller than 1, then it will decrease. But the direction remain unchanged. For example, this one. Let's say you have a vector a bar, and then if I multiply it with the number 2, then only the length becomes twice the length. It becomes doubled. Can you see or not? So this length is, let's say, 10 centimeter. The length here will be 20 centimeter. Okay, because you are multiplying with a number 2. If you multiply with half, then it becomes half the length. Understand? What about if I multiply with a number, let's say a negative number? Okay, so I have a bar out here. If I multiply it with minus 2a, if I multiply it with minus 2a, then in that case, it will be, in this way, the length will be that way, but the direction will be changed. So this is minus 2a bar. Is it clear here? So minus, if you multiply with minus 2, only the direction will be opposite to this. Is it clear or not? So when a vector a bar is multiplied with a real number, it becomes n a bar. The magnitude can increase or decrease depending on the value of n. Okay, but the direction, no, the direction will change. Okay, the direction will change because here, then if you multiply with minus 2, we can see that the direction has changed. All right, its direction is same or opposite to a according. Okay, let me just while the direction, let me rub off this part. While the direction remains same or opposite to a bar. Okay, so it will remain same if you multiply with a positive number. It will be opposite if you multiply with a negative number. Okay, so that is one important bit of point that I nearly miss out. Okay, right, now unit vectors in Cartesian coordinates. We are very familiar with the Cartesian coordinates. Okay, we have the Cartesian coordinates. This is the y. Okay, let me draw it fully. This is the y-axis, and you have the x-axis, right? And let me take different colors for you to understand properly. So let's say I have this x-axis, and let me take this color. This is z-axis, right? So if you go this part, this is called the origin, right? This part is the origin. Yes, 0, 0, 0. Okay, that's the origin. So origin is a point from where you measure the distances, is it not? So if you go towards the right side, then this is positive x. Yes, if you go towards the left side, then this will be negative x. If you go up, this will be positive y. If you go down, this will be negative y. And from here, if you come outward means perpendicular to the plane of the board, and perpendicularly outward, this will be positive z-axis. And if you go perpendicularly inward, this will be minus z-axis. Okay, and since these Cartesian axes has got direction, so they can be represented by unit vectors. Okay, their directions can be represented by what? By unit vectors. Remember, what are unit vectors? What do they represent? They represent the direction. Right, so here along the positive x direction, we have a unit vector I cap. Okay, now don't ask me why I cap. That is just the general rule, that along the x direction you have a vector. The unit vector is denoted by I cap. Okay, and this will be minus I cap. All right, along the y, the unit vector is j cap. And down, this will be minus j cap. Along the z, along the positive z direction, the unit vector is k cap. And in the negative z direction, it will be minus k cap. Got it? So this is just the rule that is acceptable worldwide. All right, that I cap, it is the unit vector along the positive x direction. Okay. J cap, that is the unit vector along the positive y direction, and k cap is a unit vector along the positive z direction. Understand? So we can write a vector. Now in terms of the I cap, j cap and k cap, we can write vectors. Okay, let's say we have a vector we have a vector r bar. We can write this in terms of I cap. So let's say we have here x I cap plus y j cap plus z k cap. You see? So what is this? This is called the x component of the vector r bar. This is the y component, and that is the z component. All right. How do we know? Because of the direction, because this is in the positive x direction, this is in the positive y direction, that is in the positive z direction. In general, we can say, let's say a force of 3 I cap minus 5 j cap plus 2.5 k cap Newton. Okay. So what is the meaning of this? It means that this force has a component 3 Newton along the x direction. It has a component 5 Newton along the minus j direction. It has a component 2.5 Newton along the positive k direction. Understand? So this is the general form of writing vectors. Okay. So those are the properties of vectors. All right. And I want you to study well these properties, because they are going to be important.